Hi, everybody. As you probably gathered, I'm Wendy and this is Ricky, and we're from Pad Studio Architects. We're based in Lymington in Hampshire, and we're going to talk to you today about our New Forest House project, which the clients approached us back in 2008, so quite some time ago. We won a sort of mini competition to design this house. And first of all, before we get into the post-occupancy study, I'm just going to briefly introduce you to the project and just set the scene a little bit. Next. So this is the site is in the north of the forest. Well, it's just south of the motorway, actually, near Minstead, and it's in a very beautiful part of the national park, and it's very, very conserved here. Not only is it a national park, it's a SSSI, and the client owns 18 acres of New Forest. And so Natural England were very involved in the whole process here. And you can see this is the existing site plan, and I don't know if we can use the cursor, but yeah, the existing house was in here. It was a very small shack, basically, was the term the planners used for it. It was a mile down a sort of unmade track, and you can see from all the trees here, a lot of beech trees around it. It was really tucked away, you couldn't see it, but the views from it were absolutely amazing. South facing views over the forest, right towards the Isle of Wight, just stunning, and architect's dream. So we were very excited, but there was a bit of road noise that we were getting bounced back because of the topography at certain times. So our brief from the client was very straightforward, actually. They wanted to design a low energy and contemporary home that was appropriate to the setting, that one that treads very lightly on the earth and with a natural swimming pond, and the rest was up to us. And actually, one of the reasons why they were very interested in sustainability was that one of the clients suffers from non-Hodgkin's lymphoma. And so it was very important to them that even the paint on the walls is organic. And that's one of the reasons why they wanted a natural swimming pond, which we hadn't done one of those before. In fact, we hadn't done very much of what we did here before. So it was all a bit of a learning curve. So as I said, beautiful, beautiful site, major planning battle. National Park had just been formed, didn't want anything contemporary. The site had been identified as a SSSI from the air, and there were dew ponds nearby. So that was one of the reasons why we paid a lot of attention to the roof, and we introduced a sedum roof here. And we worked with a chap called Dusty Gedge on that, and we actually had to develop even our own seed mix because Natural England didn't want any infiltration of the SSSI, both with the hydrology of the swimming pond, anything that was planted in the garden, and any of the seed mix on the roof. And so the concept that you can see here is very simple. It's just, it's a house of two parts. And that's because the existing footprint of what was there was very, very small. It was 85 square meters, and we could only extend that by 30%. But they did have a separate room at the back of the garage that they used very legitimately for guests. So we managed to negotiate a guest annex. And because of the extent of the size of the site and the extent of the land management, we negotiated a basement, which was within policy. So not very environmental, I can hear you say. However, it was quite often, and it does perplex us when we do basements, but quite often the sites that we're working in are so constrained by their size that there is no option other than to go down. So we wanted to use stabilized rammed earth, and we got samples made by Bath University. We wanted to use the earth from the site, and then we found the soil particles weren't going to be the right size. So, and even with stabilized rammed earth, you have to build a concrete wall behind it. So we thought, well, this is going to be very expensive wallpaper. So we decided to actually use concrete and just do it in a very honest way. So we worked with a chap called David Bennett because we were really aware that concrete has a high embodied carbon content. Even back then, we were thinking about embodied carbon. And so we worked with David on a very specific mix. And we looked at the color, we sourced local sand, we worked with a local plant. We sourced a mix that had PVA in it, which is pulverized ash. And because we were exposing the finish of the concrete here, we couldn't use GGBS in it because you can't use that in finished concrete. But what we did do was, and these are some of the very early sketches from the conceptual narrative that we did. The concrete that goes is a container for the earth that's dug out to form the basement. So that's all burned up on the north of the property. So the wall is actually resisting the pressure of that. And so none of the excavation was taken off site. It was all kept on site. And we used this sort of device of this spine wall, which runs down into the basement and across to the annex, as an architectural device, but also as something to shelter the house from the acoustic, from the noise a little bit of noise reverberation that we were getting from the motorway. So it's a really beautiful thing. We sourced timber from just down the track, Douglas fir, which we used to line our formwork, and then we reused that to build the garage. So for us, the consideration of the materiality was really important. And here you can see that spine wall element, which runs along the back of the house and then runs down into the basement. And with the basement policy, you can't have any windows down below the earth. But what we did manage to do was we've got a roof light the whole way along the stair, and we've got some roof lights set into the earth berm, which wraps around the house, which gets natural light down into the basement. And actually, Ricky will pick up on a point a bit later on with one of our sensors that we used in the post-occupancy study is located on the back of this wall here, and is potentially picking up some sunlight, which is interesting. So you can see very, very simple plan form. The bedrooms are very small. We wanted just to maximize the feeling of space in the kitchen dining room, and we've got a completely separate annex. The whole house is in situ concrete. And the annex is timber frame, and that was a very deliberate choice of construction based on what we knew the occupancy patterns were going to be. So the annex is completely standalone in its services. It's got a log burner with a back boiler, and the idea was that if they were away, friends could come and stay and they could be completely self-sufficient. So the main house, we really wanted to use and explore thermal mass, which is why we chose to use the concrete. And that's worked very well, as the post-occupancy study will dive into that in a lot more detail. We obviously have a lot of south-facing glass and west-facing here, so the view is down here. And as the sun path moves around, we thought, well, there is the potential for overheating here. And we did do a form of dynamic thermal modeling back in 2010. And as a result of that, we designed these solar screens, which are slatted, which actually, they fold back into pockets, or they can they can be pulled over all the windows. And we estimated back then that would cut down the solar gain in the house by about 70%. So it was absolutely fascinating then, when we did do the post-occupancy study, to see how well those were actually working. So we've only got them over this part of the plan. And so we've got the solar thermal gain, we wanted the solar, so we've got the thermal mass, we wanted the beneficial solar gain in the winter to be absorbed by the thermal mass, so that it would, the idea was that that would even out diurnal fluctuations in the temperature. I think back then, the U values were pretty good for, well, they were very good for 2010 when we were designing this building. And again, it's really interesting to see the effect of that now. I think one of the windows were thermally broken, but there wasn't nearly the choice of window on the market back then as there is now. And we have used NVHR throughout the house. It was absolutely critical in the basement to maintain fresh air. That picture on the right here is a bedroom in the basement, and so that's natural light that is flooding down. So there are people sleeping down there, and as a result of that, we installed a sprinkler system as well. And that was quite a challenge because all the water that's used in the property is from a well. So the well was an existing feature, and we worked with a specialist and installed UV filters. And we've got a storage tank that's filled with water in case there is a fire and there's a power cut. So in terms of, so we've got NVHR, which is brilliant, recirculating the air, keeping that fresh, taking warm air from kitchens, bathrooms, and recirculating that. And we've also got a ground source heat pump here, which is vertical because of all the tree roots. And I think at the start, we thought we would have 6 boreholes. And in the end, I think we had 2 or 3, but we went down to 100 meters. Just that's what we found at the time when we did the boreholes. And I've mentioned the cedar roof. We've also got solar thermal panels, which are used to heat the hot water, which have worked very well. And those are on, there's a little pop-up here, which is a roof light on the back of that to get some natural light into the bathroom. So we've got solar thermal on there. And then we did plumb the house for grey water recycling, and we did put in all the wiring for PVs, and the PVs were added a little while later, and actually they've been installed in a ha-ha at the bottom of the garden, so they're very accessible, easy to clean, and you'll see an image of those in a little bit. So what have I missed in terms of that? That's sort of a summary of the environmental strategy that we put in place at the time. So I'll just hand over to Ricky to dive straight into the post-occupancy study.
Yeah, so this building I didn't work on at the time, and it was before my time at PAD, but I joined actually quite shortly after it was completed. And since I've been here, we've built a number of buildings, and we've been really keen to actually go back and say, okay, well, what is actually happening on them? And this project in particular, we've been in contact with a client ever since it was completed, and we've got a very good relationship with them. So we've always had updates, gone back to the building a lot, taken a lot of potential clients there. So we're really used to what's been going on. So anyway, so we start to formalize our approach and said, okay, well, let's select a number of buildings, and we're going to really delve into what's happening. So our key thing was, our key approaches, there's four things to that, is client communication. So we really want to understand the client's experience and what's going on for them living in it, what value it's had on them, both like experientially and to their family and friends and various things, you know, events that have happened in this house. And then drilling down from that into kind of more data side of it. So we've used Permetrics, we teamed up with those, researched loads of different companies, and at the time we joined with them 2 years ago. and found that they had the best software and data collection for us that was the most accessible. And none of us in our office are trained as environmental science experts or anything like that, and we're all architects, and it's something we're wanting to understand further, but we needed everything to be accessible. So in this particular project, we installed 6 sensors all around the building. It turned out about 4 sensors provided suitable data to be analysed, and they measured temperature, humidity, and CO2. So we had a CO2 sensor in the living room, and then temperature and humidity sensors around 2 in the living room and in the bedroom. Here you can see the location of the sensors. So we had so there was one in the basement. We had some in the annex, but we didn't get strong enough signal with the gateway sending the data through in the annex. So our best sensors that we had were these 4. It's really fascinating what occurred with the sensor up on the northern side of the building to the south. And actually this sensor had a continuous, all the way through the year, a 1 to 2 degree difference in temperature performance. And this is an open plan building. And there's a few theories that we're wondering of how that, and we've got to look into this more. But actually what we're thinking is that area is 500 mil above the base level where the other sensor is. So the sensor is 500 mil higher because they're measured off the floor. And also we think there was quite a lot of radiant heat coming from the concrete wall, which radiates back towards that sensor. So that whole area, what we start to understand, that whole area maintains a lot more heat, even though it's got the huge glass roof light above it, than the sensor on the south wall. So it's really fascinating watching that data come through. And the other data we looked at is energy use and generation. So I'm not really going to talk about that stuff, actually. We were asked to do this presentation, and that data we have looked at, and you can go on Design. There was an article recently about some of that information that we pulled through, comparing it to using as if the building was used, if it used gas instead of the ground source heat pumps. We can get comparisons as to why explaining to our clients why use ground source, why invest so much money up front, and various things like that. And then the last process of our post-occupancy is looking at this data against the original specification and the original design. So I actually only started doing this a few days ago, because once I started looking at kind of my part of the presentation, I've been through all the figures and the cost figures and running of energy and stuff. And what I hadn't really got around to drilling down to is the data that the Parametrics can put out in terms of the temperature analysis and various things. And now I really started looking at what that means in relation to the original thermal modeling. So taking you through this, so this bottom table right at the bottom shows us that is an extract from the original thermal models that were completed way over 13 years ago. Now back then, TM59, TM52 didn't exist. I think that came in around roughly 2017. If I say anything incorrect about TM59, TM52, someone step in and do correct me. Again, I don't actually use that software, and we work quite a lot with Mesh, and we've been doing some new buildings through that software to analyze our buildings. So this was the original thermal analysis. It has a completely different weather file than new projects are analysed against, and also the temperature. So the period over temperature, our target temperature, was set at 25 degrees back then. Nowadays, the models are set, the peak temperature is set at 28. And also the external temperature was very different in that thermal model. So in that thermal model, the external temperature, max temperature, was set at 28 degrees, peak external temperature. Now, real life temperature in July at that site, it peaked at 35 degrees. So between the model and real life, there is a 7-degree difference between what's happening, and that's massive. And this really highlights to us how important it is that every model that we do for every new building, we need to be modeling the most extreme possible cases that we realistically can. So up on these 3 boxes on the top, taking each room. So we looked at a period. Between May and September in 2022, and the top information gives us the full 24 hours. So I haven't extracted occupancy hours there. So in the master bedroom, we were getting a temperature of 20 degrees minimum, 29 maximum. And during that period, we exceeded that 25 degrees, which was originally modeled on, by 10%. And it gives us the number of hours as well. Now, if we actually compare that room with the modern TM59 parameters, looking at 26 degrees and so forth, and during those occupancy times between it's actually 10 p.m. and 7 a.m. That's written incorrectly. We're actually at total year 0%, and between May and September, we're only actually 1% over. So looking under those modern measurements, which are more accurate, actually, the building performs within that. If we look at the living room itself, again, 19 degrees minimum, maximum 31, and it exceeded the 25 degree temperature by 15.5%. And if we look at the occupancy times, that we exceeded it by 20%. And this is where it's interesting. If we look at those 2 sensors that I talked about, the one on the north, one on the south, the one on the south side wall comes in at 8% over, and the one further up in the building, which I was saying we're getting that radiant heat from the concrete, that's 25% over. So it's showing to us that area, we're getting one heat coming up from the basement, but probably very minimal because the basement's very steady temperature, and actually more heat radiating off that concrete wall.
Ricky, just as you mentioned sensors, Harry asked the question, and I'm not sure if I've grammatically going to read it out correctly, but he said, what was the reason two sensors didn't give suitable data?
Okay, so they basically kept cutting out. So the sensors rely on sending the data back to a gateway and sending it to the internet web platform, and it kept cutting out way too much. So we didn't have a concrete enough amount of data to be analyze those rooms effectively. It was very limited. And
was that the distance from the master controller in the annex?
Yeah. So next time I would put in more gateways around the property, and so we can get steadier connections through that, basically.
Okay, cool. And
yes, it's achievable to do. It's just, we need another master.
Yeah.
Which is more money, and we were paying for it ourselves.
Sure. So to ask an unqualified question, when you worked with your data partner, even though this was done, you said you started working then 2-3 years ago. Yeah. That's right. So the study effectively, even though it's like the work was done 13 years ago, you had your initial benchmarks. They've come in, they've confirmed where you are, hence your figures in relative to TM59. And then when you had your original guidelines, did the client say they don't want to exceed 25 degrees, or is that the accepted sort of temperature at the time for being comfort?
I believe it was just at the time what was discussed. I mean, obviously wasn't on the project, but reading through the original documentation, which actually is not as extensive by any means in some ways as what's done now. I mean, the modeling now is like so much more advanced, whereas then everyone was starting out in it. So the knowledge was very limited, and the 25 degrees, I don't know exactly where that came from, but it certainly wasn't from the client saying that their comfort zone.
Right.
In terms of the client experience, discussing it with them, they've never had an issue, even when the building's overheating, felt uncomfortable or anything like that. So when it looks like it's overheating, when we're comparing it, they've never.
Yeah, and that's partly because with the shutters, you can open the windows, have the shutters fully drawn across the building, and have the roof light is openable. So we've got cross ventilation, which purges the building as well. So that works really well. That high level of ventilation at the back of the building.
Ventilation, it's critical.
Yeah.
So staying on that living room area, if we compared the occupancy time during May and September, that room would be at 1.5% at 20, comparing it to 28 degrees, not 25. So what it's highlighting is actually there is a region around 26, 27 degrees, which we're getting, that's where the most of the temperature is. It's not beyond that. 28. And that, when we look at this, I mean, hopefully people have been scanning over this sheet, but it's interesting. This original investigation looks at investigation 1 in the original model, looks at everything, all the windows closed and no external shading. And then investigation 6 looks at all the windows closed with external shading, which we did put on. And what was originally modeled was external shading to the full south elevation, not just the living area, but actually the kitchen and the bedroom. So shading wasn't put on the kitchen and the bedroom. And as a measure, if the clients wanted to manage the overheating even more, that would be one thing to do, is you could put the shading on there, which could be open and closed as needed, which would improve those measures. But that's not something they felt like personally they've needed to do. But maybe someone else living there would be different experience of different temperatures. And then looking at the basement, as you'll probably know, things underground, very steady. The basement really had very little fluctuation in temperature, had a very steady temperature. It has got underfloor heating in there. We've also got a lot of the plant down in the basement, and those two bedrooms. So, but actually the temperature doesn't really fluctuate at all. So this is an example of just one of the types of data graphs that you can pull out from Permetrics. And this is why we like it, because we can access these graphs. It makes things visual that we can start understanding and comparing to. So I've just pulled out a couple for today. So this is looking at the full, or the one on the left is looking at the full ground floor, so the living room and the master bedroom in August. And August at that time in 2022 hit temperatures. So here, this band of 32 degrees between the 11th and the 14th of August. It was 32 degrees on site in that area. And our internal temperature maxed out. You can see this red band in the middle maxed out at around 28 to 30 degrees. And this is really helpful for us to start understanding how the building is cooling itself and warming itself with this solar gain. So you can see where it's been managed with shutters, and you can see where the outdoor temperatures have made an impact with this, with the temperatures outside and where we're getting extra solar gain. So you can see here that quite likely good management's been happened with keeping out the solar gain and good ventilation, because the temperature hasn't risen in this time. These blank spaces are where we've lost connection and lost data. And then,
I mean, that's important to say, isn't it, that those shutters are manual, so they do rely on client interaction and control.
Yeah, absolutely. And then just as an idea, in August, so that 25 degrees we exceeded by 30% in total hours, and if we looked at it in 28 degrees, we're exceeding by 4%. And then just as a comparison, just so you can see how these graphs are working, I've put the basement on the right-hand side, and we're getting very little variation, 2.6 degrees. You know, it doesn't really move at all during that hot period. And actually there's a period after that. So this lag in temperature increases after this hot period, which is interesting in itself. Yeah, and that is pretty much it. That's an overview of the
solar PVs.
Solar PVs and everything, so you can see this southern elevation.
I mean, what we haven't got on here, which is now starting to be really interesting, if you go back to that graph separate, is to compare this to studies on other houses that we're doing, which have different forms of construction, different levels of insulation, and compare the same months and just to see what's happening at different occupancy patterns. We did that yesterday, actually. We were having a look at another house, which is timber frame. It's got much higher levels of much higher U values. So on paper is a better building from that perspective, but its occupancy pattern is completely different. It has high level windows, and we haven't got the same degree of control over the solar gain. So the graph was just, it was startling, wasn't it?
Yeah, difference in performance.
Yeah, and one of the reasons why I guess Ricky and I were really interested, we've always, environmental and sustainability issues are just so, part of what we do, but we were just wanting to learn, which is why we engaged in this. And we actually went along to one of the research units, a couple of the research units at the RIBA, looking at post-occupancy, because this was, 7 years ago. And we were looking at what was out there, and, for mere mortals like us, actually trying to just look at the data and understand it. There just was not very much that was, you needed a PhD to, look at the output from it. And we were quite shocked when we sat around the table at the RIBA, with, the great and the good, some big practices. And what they were saying was the complexity of gathering post-occupancy data, especially on bigger projects and GDPR, is really enormous. So that actually, even the data that we can gather on single houses is really beneficial, and to share it with other people and discuss it, even if it's not great. Well, we need to learn. One of the things we've learned is how important it is to include and to design in the solar shading from the word, from the off, and really to interrogate the clients as far as we can on their occupancy patterns and their expectations.
Yeah, the architecture is so different now. I mean, this is super exciting. Yeah. I absolutely love this. This is like amazing. But it should be, this needs to be discussed a lot more in architecture schools and stuff like that. But it's super exciting to be able to look at that data on your buildings that you actually build and are live, and you're like, okay, I've worked on that, you've made decisions on it, and now you can start assessing it with real life information. And now we're
real life people.
And now we're setting up a way, our own protocol as such. So how we're going to measure it, times, stuff like that. So we can kind of keep as close as we can our own methodology to be able to compare our buildings. And I just think our issues are different. We've got to explain to clients that the issue now is not that you're going to get cold. It's actually designing out overheating, yet people still want big views, big expanses of glass, and various things. So it's educating our clients in that way as well.
Definitely. I have a couple of questions regarding that, but before, Alex, did you want to come off mute? You've probably got more than one question, I imagine, regarding the thermal mass and how to manage the heat.
Yeah, thanks, guys. It's been a very interesting presentation. So I do have a few questions. One of them is, really is whether you think that the thermal mass can actually become a hindrance in a building, particularly if clients aren't managing their solar shading well or the night purge well.
Well, one of the reasons that we initially wanted to use the thermal mass was, I guess, potentially in the winter, we were thinking about it more. So we were thinking about, during, we've got this glazing, we're allowing the sunlight into the building. We've got the exposed thermal mass. So what that's going to do is absorb this fantastic solar gain during the day and release it at night. So we were thinking about it from the perspective of being cold, and using the warmth. And so what's really interesting now is to see during, the summer months as well, is that it's stopping that excessive fluctuation as well. But it was really interesting to see the time lag, wasn't it, in that second graph. What would be brilliant is if we hadn't had those gateway issues, and we could have compared the the timber frame building to the concrete building.
Yeah, because from my own experience in my house, I live in a passive house. I have external Venetian blinds on a lot of the kind of problematic windows, but in the areas where I don't, it's a concrete slab. It absorbs a huge amount of solar energy in a very small area on a sunny day, and so if you don't close blinds when you need to, it then becomes a huge problem, because obviously it's outputting heat
absolutely
through the night as well.
It's doing the thing you want it to do during the winter, but it's doing it in the summer. Yeah.
So as you mentioned earlier, I mean, getting the shading right at the design stage is absolutely key.
And also, I mean, what really interestingly, we, back then, it was 2008, 2009, when we were designing this. There was a lot of discussion around thermal mass at that time. And actually, one of the house that we built a few years after this house, we used, oh gosh, I'd never do it again because construction-wise it was a nightmare, but we used the thermal mass on the ground floor, and we used timber frame on the first floor. So we had a change in construction for the, so where the bedrooms were located, they were lightweight for that, for this reason, because we did more thermal modeling, and that was okay. We wanted the heat on the living spaces, but not in the bedrooms, where you want to be able to cool the space quickly.
Have you done any modeling yet? Because the thing that people always talk about thermal mass, but they don't tend to talk about the decrement delay and the different properties of different insulation materials very much. And from experience, and I'm sure anyone that's been in a room and roof conversion that's got foam insulation in it, it might have a good U value, but it's really spiky compared to if it's wood fiber or something like that. And I wonder whether, so my own house is a timber frame. It's supposedly lightweight construction, but it's got 300 mil of cellulose, blown cellulose in it. So even though it's meant to be a low thermal mass building, because the decrement delay is so long, it really flattens out the temperature spiking. So I wonder really whether you had any research yet or occupancy analysis on those sorts of timber frame buildings, or whether they've all been kind of rock wall and timber frame type buildings.
Yeah, do you want to talk about clay? Because it's got concrete, we've got the thermal mass on the floor, and we've got timber frames on the wall. So
yeah, I mean,
it's hybrid.
It is hybrid. I mean, it's not a fully thermal mass approach, it is a timber frame building, and there is a huge amount of there's a huge amount of solar gain in there. They chose not to put the shading on, and they wanted to see how the building performed and then retrofit any shading. They still haven't put anything on. And but the slab makes a huge difference to that. But we haven't got any buildings at the minute that we've measured that are a full thermal mass approach to then compare it to a full timber frame approach. Thinking about your earlier question leading on to this, in my view, it's thinking about it completely differently, that if you're working with a thermal mass approach, and that's what you want your approach to be, we've got to think about that differently. We've got to think like we're designing in the desert. And I spent some time in Morocco working as an architecture student studying there. And when we were looking at the traditional architecture, we were using the thermal mass in a passive way to do a job. And we could do that here quite easily, where you don't rely on client management of shading and so forth. So I think we would need to think about that differently, and also where the thermal mass is located.
But they're not putting full circle glazing facades of glass.
No, but that does mean that what you've got to do is get your overhangs right and stuff.
Absolutely.
And these are things,
and the shading.
and these are what clients have got to completely understand as well, especially if you're designing a very
because if the glass has got warm, you're defeated.
Yeah, absolutely.
Because you're just going to get the radiation anyway.
So, but you've got to think about that differently. Before we were always thinking you need some thermal mass and you need solar heat gain. Actually, our insulation is so good now, we don't need any solar heat gain. You effectively could design solar heat gain out and have such a high performing building that that you don't need that extra passive measure of temperature.
Yeah.
So I think we do need to get our heads around that and how it's working. And also where the thermal mass is located. Is it on the outside, and we're trying to keep that temperature out all the time, or is it in the inside where we're wanting the radiant coolness of that thermal mass to be near our skin because we like the building to be generally cool. We like that cool feeling. Whereas we have some clients where they want their house at like 28, 30 degrees. It was mad. They have the heating on in the summer. And I just found but that was their preference. So yeah, don't want to draw that question out too much, but wow.
Well, thanks for that.
Cheers, guys. And then from a modeling perspective, and sounds like you'd like to do this with every project. I mean, what's as a percentage of the build cost? I mean, with your conversations with clients, is it? I mean, how do you price this? Do you almost say, well, this is what we're going to charge, and with it you get X, Y, and Z, and it includes the modeling? So therefore, or it's always like, oh, we're not so worried about that.
No, we price it in. I mean, we've talked so much about this. Right at the start when we're doing our, we've got an initial job inquiry. We send out a very detailed client requirements document, and within that, we raise the issue of post-occupancy and to assess whether there is something that interests them. We ask them a lot of questions at the start about sustainability and, just to see where they sit. And some clients, they like the idea, but they don't, they don't have a great deal of knowledge. They want to do the right thing. And increasing, so there's a process of education goes on, but I think right at the end of a project, there is never any money. Generally they just want rid of everybody because they just want to get on with their lives. So I think we just price it in earlier on, and we just put aside, because we want to learn, and sometimes, and that's really important to us. So it's just priced in, and we just,
we have our own research budget, and that's what we commit to. Rather than sending our money, any money out to other charities, we said, actually, why don't we just do our own research? And so that's where we put the money, basically.
No, interesting. Because I mean, I suppose, and then obviously from a client perspective, your research shows them why you're making certain decisions. I mean, going back to what you said, Wendy, even if the results aren't good, well, that's laudable, and I understand.
Well, it's an interesting one, because we've had one client sort of plaguing us to do it, and we were like, he's just going to use it as a stick to beat us with.
And then what happens? No, it's that was that. Exactly that. Sorry, I'm trying to read Gavin's question. Oh, Gavin's asking a very pertinent question. Would it be rude to ask how much this study did cost?
Well, you can ask, but we have no idea.
I mentioned.
We just we just, yeah,
You
we
just
should,
do it,
we keep very detailed timesheets, so we, you know, we could give a figure for that. I mean, it's a good question, actually, and we should find out the answer.
We'll give that to you later,
Yeah.
but I haven't actually finished the study. So, I
Yeah.
mean, this is, I've only just touched the surface today, and what I want to do is write a full report, which, you know, we'll eventually share
Yeah.
on the buildings. There'll be more time to put in, but effectively the cost is
Time.
yeah, my time in the office, but also my time not working on a fee paid project. So it's getting that balance, and then the equipment.
Yeah, we use, you know, people have said, well, you know, how long do you gather the data? And we've got, you know, a certain amount of equipment which we'll probably have to buy more of. We've got 2 sets, have we?
Mm.
So we keep it in for a full year. So we're gathering 4 seasons, and then we're taking it out and putting it in another project, because
Right,
it's not a
okay.
year, you're not going to get any great benefit from having it in for 2 years, because you know. So that's what we're doing. It's slowly building up. So I think, so we got it in, we're going to put it in Chestnut Farm,
Yeah, so
which is very low thermal mass. So that will be interesting.
yeah.
Harry did ask in terms of like the cost, how much do you reckon that equipment costs?
Oh, the equipment's cheap. It's, you know, relatively speaking, it's what?
Yeah, I think
500 quid.
I think we're about £500-600, and then for the 2 sets, and then we pay a yearly subscription of a couple of £100.
I will say Parametrics are brilliant. They're really keen to help, to discuss. The MD Hermione is really proactive.
That was the key thing when I looked at other companies. There's some brilliant tech out there, but I had to learn the tech way too much, and also
he's very good at tech.
They didn't have a way of processing the data, so then I would have to learn how to process data, and I don't have that background. Whereas Parametrics have a whole way, you know, all these graphs, they've already figured out the science. I just need to put in the metrics that I want to measure, and then I get the information out. So, I mean, if anyone wants to, I'm happy to discuss, if anyone wants to discuss it, you know, if they get in contact with you can put them in contact with me if they want to, you know.
Well, that'd be helpful. Thank you. Chris, did you want to come off mute and just ask your questions?
Yeah, is that working? Can you hear me?
Yeah, we can hear you. Thanks, Chris.
Okay, great. Sorry. Yeah, I don't know if I missed it. You were talking about another house you did with high thermal mass to the ground floor living and low thermal mass timber frame to the first floor.
Yeah.
I can't recall. Did you conclude that worked well in the end for occupant comfort and thermal performance, or not? I don't know if I missed it.
I think yes, it did. It did work very well. On that one, we worked with Professor Doug King, and he is an environmental scientist. And it was, in terms of comfort level, it worked very well. It was more constructionally the change from on site, and practically it proved to be a bit of a nightmare, changing from thermal mass to lightweight construction. So, and just all the junctions was very time consuming. Yeah.
But from a comfort point of view, just the practicalities of that, what is it? Is it that the bedrooms that were easier to keep cool in the summer?
To cool down more quickly, yes, through purge ventilation. Yeah, because not having the radiant heat being stored and released in the same way as you do with the thermal mass, which is beneficial in the winter, but not in the summer. But unless you keep the radiant heat out, and that's what we're saying, that's really vitally important. That's where the solar shading comes in, so that the thermal mass isn't heating up in the first place. But you have to be really proactive about that.
But on that house, would you not also in the hot summer want the living spaces to be cool in the same way you'd want the bedrooms to be cool?
Yeah, but you're not in the living spaces overnight. So it's not such an issue.
Okay, interesting.
Yeah. In the daytime, they're cool because you've got both, because they're absorbing the solar gain, and then that it'll release the heat in. So in the winter, brilliant. Is really brilliant. But yeah, because the bedrooms, I mean, it was a bit of an experiment, but just to see that's what the modeling suggested would be the ideal situations. We thought, well, why not? Let's give it a go. So it would be really interesting to, we need more sensors, we need more time, get them in
more flowers for the clients.
Yeah, exactly. Get them. I'm sure that client would be up for it, but yeah, so we should put them in there and put them upstairs and downstairs and look at that.
Thank you. That's interesting. Thanks.
Cheers, Chris. Thanks for the question. Stephen's asked, have your findings affected the way you approach designing a passive house?
Well, I don't necessarily think, we try to design it. It doesn't really matter whether it's a passive house or any house. I think our design approach is exactly the same. And we're very conscious of shading and large expanses of glass. Yeah, got any comments on that one?
Yeah, and it has changed and been even more thorough with what the client's ambitions are for their experience of their house in terms of comfort.
Yeah,
comfort.
I think one of the things that's been we've been really trying to look at recently is embodied carbon as well. So I think we inherently, our approach to design is very rooted in passive house. Not all our clients choose to do the certification, sadly, because they just feel that many of our clients aren't, they're it's their forever home. Doesn't mean anything to pay an extra few £1,000s to have a certification if we're putting it through the same process.
I think what it's highlighted actually is I think previously it felt like we had to do big moves. I know when I started in architecture, it was all about big moves. And now it's like these marginal gains for any cyclists out there. It's all about these kind of marginal gains, but also marginal differences that you can make. And actually, the tiniest impact of window size to shading ratio can make a huge difference. And it's very sensitive now. We're talking about high-end. We were talking about this to a new project that's just been finished.
Yeah, this is really interesting.
And the clients are not really that interested in environmental design. They're kind of like, well, yeah, okay, yeah, I'm on board, but don't make it cost me more money, kind of thing. But for us, we explained it through, well, actually, you're building for them a Maserati. You're building a high-end, fine-tuned machine, and that's how we have to think. We can't think like big bricks and mortar so much anymore. It's very technical, and we need to deliver like that now, and measure like that, and design
like the
like
overheating study in England.
Yeah, and we went through hundreds of iterations, just fine-tuning actually a project we'd done recently, just with mesh, just fine-tuning hundreds of iterations we ended up having to do. But it was worthwhile. A lot of learning.
Cool. One last question, just as we approach 1 o'clock. Rajendra's asked, did you install EVC? And does this sap the battery storage? Presumably that was done retrospectively.
Yeah, we have. And I think we had to, but also what has sort of thrown some of the data in, we've looked at, the bills to analyze this, is the client has a pottery studio and is running a kiln. So that's been a lot more impactful than the battery, the car charger.
Yeah, client lifestyles are massive and getting clients to realize that. I mean, we have to watch our lifestyles in terms of the way technology is moving. We're all charging so much stuff now. Everything's by battery. Everything I buy is like rechargeable. Yeah, it's brilliant, but also it takes huge demand. So it was interesting in that project how much they cover their extra demand with the PV and everything. And they would have huge amounts of excess if they didn't have those extra things running around the house. But you get ask the questions from the client on the outset.
Yeah. And sorry, I will make this the last one, but it's I always like the ones around the business side of things. Gavin's asked, do you have an approach to attracting the right clients who wants to create a higher performing house, or do you work to, so I need to put my glasses on, or do you work to sell the idea to each new client?
Oh no, we're completely honest, and because we are very passionate about environmental and sustainable issues, we talk about it from the word go.
Yeah,
they know what they're getting.
Yeah.
They come for a reason.
Yeah.
You know, contemporary architecture that's with as highly sustainable approach as we can possibly deliver on that project.
Yeah.
Cool. Marvelous. Okay then, guys, now really appreciate you taking time to talk to us about that. It's been really interesting. Yeah, fabulous. I will upload this recording probably tomorrow by the time I've edited it. Not that I have any great editing skills, but I just take out the bottom so you don't have to listen to me waffle on. So this will be uploaded to Meshwork tomorrow, along with all the questions. I have the deck from Ricky, so I'll share that as well. Yeah, top drawer. Thank you very much. Good luck with the award once it's submitted.
You know, if anybody does have questions and they want to have a chat, you know, just get in touch with us.
Yeah.
Cool. Thanks, guys. Brilliant. All right. Have a good day. Cheers.
Thanks.
Okay.
Thanks.
Bye.
Bye-bye.